Yes, ma'am.
Okay. So we'll first do some solve with us questions and then we can take up your doubts if there are any. By the way, has there been a problem or doubts from this week? Like, have you guys been facing problem solving the question from week 6?
Yes, ma'am, in the practice
Yes,
system.
ma'am.
Okay. Let's do the solve with us questions first. Just give me 1 minute. Yeah, okay. So we'll start with this question first. Uh, you guys need time to solve this, or can we just start this here right away? So let's solve it here only. Is the question visible though?
Can you zoom it?
Yes, ma'am.
Is it visible now?
Yeah, ma'am, it is okay.
Okay.
Yes,
So
ma'am.
you've been given this function, it's a quadratic function, and you've been asked the range of this function. So to find the range of this function, it's what you can do is it's easier graphically. Everything, especially in quadratic equations, graphically things become just easier. So if you can plot this graph, it's easy. So what you can do is you can take y is equals to x square minus 5x plus 6, and then you can just complete the square. Either you can complete the square here to make it of this form x minus a. That way it will just be clear, y minus b form. So you can just have the vertex and then the roots. So the roots of this are uh,
X minus 3
2
into x
and
2 and
minus
yeah,
3.
2.
it's x minus 2 and x minus 3. So the roots will be 2 and 3, right? So the roots are 2 and 3. So your 2 is here, 3 is here. and then the vertex is between these two. So you don't even have to look for the vertex. So between these two, you have 2.5. So you can just take this thing. And if you will put 5 by 2 here, you can find the y coordinate of the vertex. So it's this thing, right? Or you can use a direct formula for, I was just looking for the least problematic approach to this question. So you can just skip this, drawing this, or you can just directly use the formula for vertex, which is minus b by 2a. That will be the x coordinate, right? And then for the y coordinate, it will be f of minus b by 2a. So minus b by 2a here is, the b is 5 and 2a will be this, right? It's the same thing as 2.5, by the way. And then you can put it here. So this will be 5 by 2 squared minus 5 times 5 by 2 squared. Sorry, 5 by 2 plus 6. So this thing is going to give you this y coordinate of this vertex, right? And then what will be the range? Let's say this is x naught, y naught. This point, the vertex is x naught, y naught. Then what's the range?
That point to the
Why not to infinity?
Why not to infinity?
So it's y naught to infinity. Y not included actually, because you can attain this point. So this will be the range, right? So this is your y coordinate of the vertex. Solve this thing. So you're going to get,
minus 0.25.
okay, minus 0.25. So it should be this one then.
Ma'am, option D.
It would be option D. Ma'am.
Okay, this is plus, and it should be this. Okay, so it's this one. It's from y naught to infinity, and your y naught here, the y naught is the y coordinate of the vertex. The range is basically y coordinate of the vertex starting from there and ends on infinity. That's your range. So in this case, your range would be minus 0.25 to infinity. Is this one clear to everyone?
Yes, ma'am.
Okay.
Ma'am, I just wanted to confirm that did the class happen on Sunday? Because
No, there was some issue. So the class did not happen on Sunday. There was no class on Sunday.
okay, okay.
Yeah, and today's TA session also, I think.
TA session has also been cancelled, I guess.
We didn't have any information. Maybe it was shared on Discord, but we are not on Discord.
No, the Sunday session was cancelled last minute, so uh, I there was some technical issue, so I couldn't take the class then.
Okay.
It was supposed to be there was supposed to be a class on Sunday, but I couldn't because there was some problem.
Okay.
So let's come to this question. You have been given a function log base 2, and then we have a quadratic function in the argument. This is defined whenever this is, the hint has also been given to you that this is defined when this thing is greater than 0. So you've been asked to find the range of this. So to find the range of this, when you have something like this, so we know that let's come to the log function first. The base is 2, so it looks like this, right? And the range of your usual, so the range of your usual log function, if you have something like this, then its range is going to be from minus infinity to infinity, right? But let's say in the domain, if you have log base 2 and then you have fx, whose range is from, let's say, your fx is from 2 to infinity. So your fx lies between 2 to infinity. And where does this thing, what should be the range of this thing? It's an increasing, the hint is this is an increasing function. Log base 2 is an increasing function.
Minus infinity to
So if your fx is between, your fx lies between 2 and it keeps going on, keeps increasing, then what should be the range of this thing? Log base 2 fx.
0 to infinity.
infinity. One to infinity.
Yeah, because what you do here is you should be taking log base 2 on both sides, right? In this inequality, take log base 2. Because it's, as we discussed, log base 2 is an increasing function, right? Log base 2x is increasing. So if you apply log base 2 to any argument, let's consider these to be arguments. If you apply log base 2 here, then the inequality should not change, right? So I can just do this thing. Log base 2 to log base 2 fx. And then here you don't have to do because we know that it's an increasing function. So it will be infinity only here. Because as your x moves to infinity, your log 2 also moves to infinity, right? So it should be this thing. And this is going to be 1. So this function's range should be from 1 to infinity. Now coming to this particular case that we have been given. So you've been given this function, minus x square plus 20x minus 36. So in this particular case, the vertex is going to be minus 20 by minus of minus
Wow.
2.
That
Minus
is
It's minus 2a, right? Your a is minus 1. So it's going to be this. So it's going to be minus 10.
minus 10.
And then you just put minus 10 here to get the y coordinate, right? What we're doing here is first we find the range of this, as we did here. First we find
Ma'am,
the
this is
range
a
of fx.
plus 10, right? 2a, right?
plus 10.
It should be a plus, right?
Yes, ma'am. Minus b by 2a. A
2a.
is a minus 1 and
Minus
not
2a and a. So I've substituted minus 1, right? Okay, I've taken minus 2 times here. Sorry. And thanks for pointing it out. Yeah, it should be plus 10. So, and to find your range, so first you find the range of this inner function, right? The argument of log, like we did here. First you find the range for fx, that is the argument for log. First you find the range for the argument, and then you apply log on its range. Basically, that's what we did in this particular case, right? That's the same thing we do here. So the range of this function is going to be f of plus 10, right? So you put plus 10 here. Your f of 10 is going to be minus 100 plus 200 and minus 36. So this is 100 and then 60.
130. 64.
Yeah, 64. So your f10 is going to be 64. And then your range should be from 64 to infinity, right?
yes.
So for this is range of fx. And then for range of log of fx, log base 2 of fx, you should take log on both sides. So you should take log base 2 of 64. And then this is going to give you infinity
Ma'am,
only because your log is
this
yes.
f of 10 is equal to 64 is the max value, right? Because it's a downward
Okay,
parabola.
okay. Is it? Yeah,
Minus
thanks.
x square.
Thanks again for pointing this out. This is a downward
Shall be
parabola.
minus
So
infinity to 64.
yeah, it's minus infinity to 64 because it's the negative sign here. It's a downward parabola. It should be this. And then minus infinity, you don't have to take because this this thing just keeps decreasing. If you'll take the log here on this end, so it's just, actually you can't, because
We have to take a positive value of this function, positive range.
you have this thing, and then the range is this for this function. So it's, yeah, so you should be taking 0 to 64, because you can't actually substitute this negative thing in log. You have log. If you will apply log here, you can't apply to negative ones. So if your fx lies between minus infinity to 64, you can't apply log here on this end. So what we do here is, instead we restrict this range from 0 to 64. So as to, and that's the hint also here. We need to make sure that this is greater than 0. This is greater than 0. So let's take the range from 0 to 64 to make this function greater than 0. And when you take 0 to 64, you should be getting 0. And on 64, you just apply log base 2. Which is 6, I guess.
Yeah, ma'am. 6.
Wait. This one's 6, but
Ma'am, I think it is saying range of f of x. So
is it?
so range would be to minus infinity to 64 only, no, for f of x. But if we substitute in that function, then it will be.
But f of x is that only log with base 2. It's with
Hold on. Yeah, we've taken the fx that we've taken here is different from the question. So it's, hold on. This thing is you have been given this thing, and see, the range is in the log function. What we did here was, we had everything positive here, right? So what we're doing here is, if your function is, let's say, from a to b, or let's say you have minus infinity, your log function is like this. Even if you just start from 0, because you're okay, when you'll apply, that was just fine. You can just take, first you consider this only, because that's the valid range for fx. For you to do this thing, log base 2 fx, the valid range of
domain.
fx should be,
Valid domain for log.
no, I'm talking about this thing first. The valid range that you should be considering here, which is obviously also the domain of log base 2,
Yeah,
should be
ma'am.
this. Should be this thing. And then when you apply log on both sides, you can't actually do that, because log base 2 0 is not a thing. What you can do is, instead you can take log base 2 x, next tends to 0 on the positive side. This is about limits, and I don't want to go there. What you can remember for now is, when you take this thing, because when your x is near 0, in the log function, when your x is near 0, the log is tending to minus infinity, right? When you come closer to x equals 0, your log base 2 is going to minus infinity. So this thing, if you'll apply log base 2, you're not actually, I want to make this thing clear, you're not actually applying log base 2 here, because that's not something you can do. So you take limit instead. But to simplify things, what you can remember is, if you'll do this thing, you're going to get infinity, minus infinity. This is not the value of log base 2 at 0, it's the limit of log base 2 at 0.
Ma'am,
Yeah.
can we also
Simplifying.
say we can't keep negative values inside log, so that's why you are putting open bracket 0?
What?
Ma'am, negative values are undefined inside log. So that's why
Yeah.
we are taking 0 and open bracket.
And negative values in 0 is also not a thing that you can put in log. That's why we've kept it open.
Yes, okay.
This thing is the limit at 0. Limit means your function, if this is your log base 2 function. So when your x tends to limit at 0, by limit at 0, I mean when your x tends to 0 on the positive side from here, and your log base 2x tends to minus infinity. That's why we've written minus infinity there. Is that fine?
Okay.
This
Yeah,
value
ma'am.
is actually never attained, and this is not a thing. Mathematically, this is incorrect. You shouldn't be writing it in this manner. This should be, now if you'll apply log on both sides, your fx is between these two things. So you'll get log base 2, 64. And here you will get minus infinity. So this is going to be minus infinity. And this is going to be 6. So it's this. Is it fine?
Yeah, ma'am, it is clear.
Ma'am, I don't understand why it is 0 to 64 from minus infinity to 0. That part I could not understand.
Okay. What we're doing here is, you've understood this part, right? That first we find where our fx lies. First the range of fx, and then we apply log base 2 to it on both sides actually.
So for
Because log base 2 is an increasing function. Is this part clear?
yes, ma'am. So for
Okay.
fx we had minus infinity to 64.
So you had fx between minus infinity to 64. But the problem here is that you can't take, if you want to apply log base 2, you can't take the values of fx where it is negative, right? So let's say if your fx is minus 2 somewhere, you can't put minus 2 here. So shouldn't you be just taking fx greater than 0 to make sure that your log base 2 fx is a defined function? It's a well-defined function. It's like finding the domain of the function only. Finding the domain of log base 2 fx. Is it clear?
Ma'am, can you scroll up a little bit? Little more. Scroll up. On the right side, wait. On the right side, you put log f of x to the base 2, and then you put limits as 2 to infinity. What is the significance of this while solving this, ma'am? Without
Which
this
one?
also, this entire concept. Log
This
f of x
thing?
to the base 2. Yeah.
I just explained this thing for, see, your log base 2 is an increasing function. So if you need to find the range of something, the question is of this form, right? So you need to find range of something of this form. So first you find the range of this, and then you apply log base 2 on both sides. Right?
Yeah, but for any log, it's minus infinity to infinity, no? Why you put 2 to infinity here?
Yeah.
Range
Because,
is minus
okay,
infinity to
that's what I
infinity.
was explaining. Your log base 2, you're right. Log base 2x is from minus infinity to infinity. Why? Because your x is, this happens, so log base 2x is from minus infinity to infinity, and your x is from 0 to infinity. So when you will take x from 0 to infinity, your log base 2x will be from minus infinity to infinity. Have a look at here. If your x is from 0 to infinity, your log function
Understood
is
that.
from,
Yeah,
so it depends on x, right? If I'll change this
correct.
x, if I'll take fx, and it should change. And since your log is an increasing function, let's say your fx is between a and b, now you have restricted your fx. That means the argument of log you have restricted. and fx is an increasing function. So if your fx is between a and b, so as your fx increases, your log also increases.
Correct.
So if your fx is between a and b, the log base 2fx should be between log base 2a and log base 2b, right? That's
Correct.
all. That's why I've explained this thing here.
Ma'am, if the log base was half, then the signs would have
Yeah,
changed, right?
they change. That's why I've also highlighted this thing that it's base 2, that's why it's increasing. Otherwise, it will be a decreasing function when your base is between 0 and 1. Is this thing clear now?
Yeah. So basically, 2 less than f of x less than infinity is an example. Like let.
Yeah, this was to explain things.
Okay, got it.
Okay, can we move on to the next question if this one's clear?
Yes, ma'am. Clear.
Okay. This one's the next question. Now again, you have something similar. This is the function and you've been
Can you
given
give us a little minute to work on it, ma'am? Maybe 2 minutes or 1 minute. Then you can take a
this one. Yeah, sure.
question. After every question, can you give us 1
Yeah,
or 2
okay.
minutes to, and then you can explain.
Okay, all right. You can have 2 minutes to solve this question.
Yeah, ma'am.
Okay, so
Option A and C should be correct.
A, C. Anyone who wants to suggest any different answers than this?
No, ma'am. Sorry, A, C, not A and B. Sorry. It is an increasing function.
Okay. So let's solve this one by one. The first is fx is a 1, 1 function. This is your fx on the interval 0.5. So the interval is also mentioned half to infinity. Yeah.
Ma'am,
So
option
first
B.
thing is, okay, let's see which one's correct then. So for 1 to 1 function, first thing is your log. This is a very important point to solve lots and lots of questions. And your log base A is either an increasing function strictly or a strictly decreasing function, right? Depending on the base. So let's say if you have log base, here you have log base 10. So if you have fx and your fx is not a 1, 1 function, then your log base 10, it happens everywhere, by the way. If you have g of fx and you know that your fx is not a 1, 1 function, then g of fx is also not a 1, 1 function, right? What happens
Yes.
is, if you say you have x1 and x2 such that your fx1 is equal to not equal to each other, such that your fx1 is equal to fx2, this means your f, that's what you mean when you say f is not 1, 1, right? So if your f is not 1, 1, that means the g of f is also not 1, 1. Correct? So now if you look at this thing, that means this happens in every composition. If you have g of fx, if your f is not 1, 1, then your g of f is also not 1, 1. That means for your gf to be 1, 1, f should be 1, 1. That's a necessary condition, right? So here, for this entire thing to be 1, 1, your fx should be 1, 1. Your fx is x square minus x plus 1, which is a quadratic function, right? And quadratic
Yeah.
functions are by default not 1, 1. So
Then it
quadratic
is also
functions are,
not 1, 1.
yeah, this is not a 1, 1 function. So the composition
Oh.
should not be a 1, 1 function. But then you have something in the domain, which means you have been given, if you would have been given from minus infinity to infinity, then you could just say that this is not a 1, this is not a 1, 1 function, right? But you have changed the domain here.
We are taking only one side of a
Yeah.
quadratic function.
So it could be that if your parabola is this, and if you say from here to here, then it becomes 1, 1, right? We need to check the vertex of this. If this 0.5 is greater than the vertex, that means your parabola, this x square minus x plus 1. Let's say your x square, what's the vertex of x square minus x plus 1? Let's find the vertex first.
0.5.
1/2.
1/2.
2/4.
It's 1 by, is it 1 by 2?
1/2.
Something. Okay, so it's
Yeah,
1
ma'am.
by 2. Now, if it's 1 by 2, this is your
1, 2,
parabola.
comma 3/4.
That doesn't matter. We don't need the y coordinate now. We just wanted this thing, right? Because we want to know, you have been
The
given, we
domain
just
of a
need
function.
x coordinate. Y coordinate's not needed. So half is the x coordinate of your vertex. That means after half, this quadratic, if this is a quadratic function, this is the graph, right? After half, your quadratic function is a 1, 1 function, right? After, if you, okay, for this function, from minus infinity, if I say that this is fx, and fx isn't 1, 1 in domain equals minus infinity to infinity, right? Because from minus infinity to infinity, it's not 1, 1. You can clearly see 2 points where the values are repeated, right?
Yes.
But if you will talk about this thing, then fx should be 1, 1 from half to infinity, right?
Yes, ma'am. Yes,
Half
ma'am.
to
It is 1,
infinity,
1 from there.
or you can even take a to infinity where your a is greater than half. Yeah, this also works.
Ma'am, minus infinity to a also. A should
That also
less
works.
than.
Yeah.
Yeah, ma'am.
If you take this part, only this branch, then also it's 1, 1. So that means your fx is a 1, 1 function.
Ma'am, even if
fx,
half is included, it will be 1, 1, right?
yeah, half included, then also it's 1, 1. We not included half. We have, right?
Okay.
Here it's not included, okay. Even if you'll include half, then also it's 1, 1.
Okay.
Your fx is a 1, 1 function. But you have been asked about this, right? Log base 10. Log base 10 is an increasing function.
Yeah.
That means your fx1 is never equal to, if you have 2 points, how do you check 1, 1? If you have x1 and x2, 2 different points, you just want to make sure that your log base 10, fx1 and fx2, these 2 points are not same, right? For every x1, different x1, x2, these 2 points are not same. You can say that this thing is 1, 1. Isn't that automatically true? If your fx is either x1 will be greater than x2 or less than x2, right? If you have 2 different points, and either x1 is less than x2 or x2 is less than x1. And because your log base 10 is an increasing function, let's even not go there. Let's say you have 2 different points, x1 not equals to x2. And we know that fx1 is not 1, 1, right? That means either fx1 is not 1, 1 means fx1 is not equal to fx2, right? where x1 and x2 are arbitrary numbers. Arbitrary means they could be any two numbers. So if you take two different numbers, your fx1 and fx2 are not equal. That means either your fx1 is less than fx2 or your fx2 is less than fx1. You can take the other case too. Or this, fx2 is less than fx1. This implies your log, because log is an increasing function, right? Log base 10. That means this should be strictly increasing than this. If you have taken this case, and if you've taken this one, then this will get reversed. So either way, this just shows us that your log base 10 cannot have same value at two different points. Is that fine? I've explained this entire thing by if your fx is not 1, 1, then your log base 10 being an increasing function. This happens because your log base 10 is an increasing function. That's why we can say for sure that if your fx is not 1, 1, or if your fx is 1, 1, then your log base 10 fx is also 1, 1. Is this part clear?
Yes, ma'am.
This is important point here is the reason you are able to conclude that this function is 1, 1 is it's partly because fx is a 1, 1 function, and it's also because your log base 10 is an increasing function. That's why your log base 10 fx is 1, 1 in this domain. 0.5 to infinity, I guess. Yeah, so this should be correct. Then coming to the next one.
Ma'am, one doubt in the previous question. Here, see, you didn't find the y coordinate of vertex, right?
Yeah.
My question is, here it is 3/4, so it's above the x-axis. If it is below the x-axis, if the vertex was below the x-axis, then we should have again removed values from the negative part, right? Because log doesn't take negative values.
So if it was this thing you're saying.
Correct. Below the x, correct. Whatever you're trying to say, right? Yeah.
Yeah, you would have to remove things, but if your half is here, then let's say if your half is there, then they won't give you this thing, no, because they know it's not defined there.
Yeah, yeah. So I have to take the
They won't give you that
rightmost root, correct? In that parabola you have done, I have to take the rightmost root. That one. Yeah.
You wouldn't be given this option. That's what I'm trying to say. Because half is not even in the domain then.
Okay.
Then half wouldn't be in the domain of this.
Got it. No, I just wanted to understand, like, whether if that change happens, then I have to do like this. Okay, got it.
Yeah. Then you have fx is strictly increasing function on the interval 0.5. So we know that a function this is what it looks like, right? So fx is an increasing strict. We have taken the fx to be this, right? We have taken this to be fx, and in the question it's something else. It's this entire thing. So, and they're asking about this entire thing, entire composition. We know that this is an increasing function after half, right? The quadratic function, this thing is increasing after half, right?
Yes, ma'am.
So if this thing is increasing and log base 10 is an increasing function, two increasing functions composed with each other give you increasing function, right? So this is increasing then. And in fact, these both are strictly increasing functions. Fx is also a strictly increasing function, and log base 10 is also a strictly increasing function. That means this option should be correct. Depends on this thing. Your parabola is an upward parabola. That's why it's an increasing function. And then when composed with log base 10, gives you an increasing function. Two increasing functions composed. But if it was a downward parabola, then after half, your function would be a decreasing function. So this inner argument is decreasing, and then log base 10, the outer function, is an increasing function. That means that the entire thing would become decreasing. Is that clear?
From the last part, are you saying if the inner function is decreasing and the outer function is increasing, then overall function is decreasing?
Yeah. So if your parabola was downward like this, so after half, if your parabola is downward, that means it's decreasing after half. So the quadratic
Yes.
function would decrease and the outer one is still increasing. So the overall composition becomes a decreasing function. Is it fine?
It's only depend upon the inner function. If it is decreasing, then the whole function is decreasing. If
No,
it is
no.
increasing,
If this outer function is decreasing, the inner one is increasing, then also the entire thing is decreasing.
how can we like say that कि कौन increase करेगा कौन decrease करेगा कैसे
Let's say
calculate करें?
this is decreasing, this is increasing, right? So you have x1 less than x2 because your f is increasing. So your fx1 should be less than fx2 because your f is increasing. And then if you'll apply g to this. So this should be because your g is decreasing. So that means your g of x1, this sign should change now, right? Because g is decreasing.
Yes.
G of x2. That means if your x1 is less than x2, so g of x1 is greater than g of x2. What does this tell you about the composition? It's a decreasing function, right? The sign changed here, right?
Yes, ma'am.
So if you have opposite things here, one increasing, one decreasing, and it's decreasing. If you have same things increasing, or decreasing, then it's increasing. Is it fine?
Yes, ma'am. It is fine.
Okay, and then this can't be correct, obviously, and then none of the above is also not correct.
Ma'am, I differentiated and then checked. Option B, I got it.
What?
Ma'am, can we do by the differentiation method? I did by the differentiation method.
You can do it by differentiation method if you want to, but just to know, isn't this one just easier? Because you can just look at functions and then tell two
Oh,
functions
yes,
composed
ma'am.
together.
From the
This
graph,
one's
yes.
just easier.
Yes, yes. From the graph also, we can say the same thing.
Yeah. Okay. So
Just a deviation. Like, see what you wrote on the right side, no? Decreasing, increasing,
yeah,
decreasing. Like, how do you come up with shortcuts like this? Like, I, I just want to understand your thought process.
it's there's I you just check it. Maybe just set up some time with it, and you know you
Ma'am,
you
it
don't
doesn't
even have
depend.
to come up with on your own. Just it's something that you can just do. If something is being told in the class, you can just take a quick note of it. It'll be easier in your exam. That's all.
Ma'am,
Yeah.
Okay.
Thank you,
Yeah.
ma'am.
is it in depend upon the rate of increasing and rate of decreasing function?
No, it has nothing to do with rate and all because uh, we're not discussing rates here. We just want to know if it's increasing or decreasing. That's all. That's what we are concerned about.
Please repeat the question.
Ma'am,
And
wait a
someone
minute.
just asked. Yeah.
मैम वो इंक्रीजिंग डिक्रीजिंग वाला एक बार शो कर दीजिए स्क्रीनशॉट लेना है
Bella ciao, bella ciao.
यस मैम ओके डन
Okay. So can we move on to the next question then? Does anyone have any other doubt, or shall we move on to the next one? Okay, give this one a try then.
मैम वो 5.6 और 5 minus 6x
It's 5 minus 6x.
Ma'am, option C.
C. Okay. Anyone else who found a different answer, or maybe some other option that you may have
Maybe
found
option
correct?
A.
Okay.
See,
Okay, let's just, they can't
Yes,
be
ma'am,
two
option A.
together. No. Okay, let's just see. You have been given this function. Just one second. Yeah. So this is the function given to you. And then there are options on increasing, decreasing, and all. So first, let's just have a look at the inner function. Let's call it gx this time. Avoid confusion. X by 5 minus 6x. So you can just quickly test these things that this is an increasing function, right? And then this is also, so your x is increasing, 6x is also increasing, minus 6x becomes decreasing, and then 5 minus 6x is also decreasing, and 1 by 5 minus 6x is increasing then. Is this fine?
Yes, ma'am.
That means, and
The
then
whole
if you
function.
put x here, you'll multiply because this is increasing, x is also increasing, two functions increasing, multiplied together. And also what happens is it's not generally true. If you say, okay, if you multiply two increasing functions, you're going to get an increasing function, right? This is an increasing function. Basically, what you're doing is you're just putting components that are increasing. This x component is increasing, and then this component is also increasing. Both increasing components. That's why this entire thing is increasing. That means your argument is increasing, and then natural log is basically log base e. That's also increasing. So this entire thing should be increasing, right?
Yes, ma'am.
How will you please explain? Like when you put x is equal to 1, we will get -1.
X.
Okay, it's I can't be putting values here and then test if it's increasing or not. And that's not the right way to check functions if they're increasing or not. So if you want to make sure if a function is increasing or not, you need to have a valid reason to claim that it's an increasing function. Here the claim is that both the functions multiplied together are increasing, both this one and this one. That's why it's an increasing function.
Yes, ma'am, exactly.
Is it okay?
Then what is
Yes,
the
ma'am.
answer to this question?
It should be this C part.
Okay.
Ma'am,
Yes.
we should also consider the domain of a inner function because it may be increasing in some domain and decreasing in some domain.
Okay. Domain, in the hint you've been suggested to use the domain. But the thing is, what happens in the domain is first thing is you shouldn't be taking x equals to 0, right? That's very
Yeah.
clear. And then you shouldn't be taking 5 by 6, right? So you shouldn't be taking this either. I think that's the only problem with this domain
Ma'am,
part.
I found
Anything
out the
else?
domain
And
is
then,
0 to 1, open bracket.
okay, even if it's 0 to 1,
Open
okay,
bracket, open bracket.
we're not really bothered about it, but because I just want you to have the easier way out, because the domain is not going to impact anything here.
Okay.
Sometimes what happens is, sometimes the thing is, why we use the domain things in quadratic functions, because sometimes it's decreasing here, then it starts increasing, then it starts decreasing. That's where domain comes into picture. When your entire thing is just increasing, then you don't need the domain, right?
also, ma'am, this is a linear, na, so it will never take a turn to, so
Yeah.
there will be interval increasing or decreasing.
Yeah, that's why in the quadratic one, we were keeping track of when it's increasing, when it's decreasing. But now we don't, because we know this entire thing is just increasing. So we don't need to be bothered about the domain here. But if you want to do it the proper way, you can use the domain.
Ma'am,
It's
in the
not going to change
denominator,
anything.
ma'am, I
Yeah.
have a question. So, like in the denominator, it's like a linear function, right? 5 minus 6x. So it is like it has negative slope, so it is decreasing. So how can we say that it is increasing function?
This thing is decreasing only. The denominator is decreasing, but when you put it this end, okay, 5 minus 6x is a decreasing function. 1 by 5 minus 6x is increasing. This function is increasing.
Okay, got it.
This entire thing, not just the denominator. Written it here, right? So this question's done. So is there a problem in this question? Anyone?
No, ma'am,
Can
there is
we?
no problem, but I am getting confused by the domain when I was solving. I thought I got a wrong answer.
No, that's why it's, if you 100% are sure that this function is increasing in its entire domain, then you don't need to find the domain. At least not in this one.
If it is quadratic or something, quadratic cubic, then we have to check.
Yeah, because quadratic functions change the directions, right? Quadratic
Yeah,
functions
yeah.
are like this. They are not monotonic. That's why you need to do that thing. Okay. Can we move on to the next question? Yeah, give this one a try then. Can we start with the question? Anyone who's been able to do this?
Ma'am, I think the answer is 7. I got an answer 1.7 something. It is not integer.
Okay, that's
It's
fine.
around
Let's just check.
17 something. 17
17
something.
something. Let's see. Okay, so you've the questions. There is an equation given to you, which is FT is the number of people who have not yet heard about the rumor. So the number of people not have heard of it after T days. A is a constant and N is the total population in the city. So N in the very next line is given to be 10,000. Then K is a constant. This is the total population given, and suppose 100 have heard. If you 100 have heard of it, it means
1,900 not heard.
this much not heard, right?
Yes, ma'am.
This is not heard of the rumor. So, and after how many days would half of the population have heard of the rumor? So half of the population is, let's go to
5,000.
the later. It's 5,000. We'll come to that later. Before that, I think we have one thing missing in this equation, which is K. So everything, let's just write the equation down first. Your fx or your y is n e to the power minus kt, right? So you've been given time. The time you have to find, right? In this question, time you have to find. And everything else you've been given. N you have been given. Y you have been given 5,000, right? Half of the population have heard it. So Y is going to be 5,000. Y is 5,000. And then
First, we have to calculate K.
N, sorry, what?
First, we have to calculate K, then we can.
But you first need to see what's given, right? C you need to find. Y is given to you. N is given to you. And and K is missing in this equation. So for you to find T, you need everything else in this equation to be known. Your K is not known, right? K is also missing. That another set of information has been given, which is this one. Let's use this first. The N is 10,000. That's constant. Then e to the power minus k, you have to find. E is, y is given to be 9900. After what? How many days? After the first day. So your t is 1 here, right? This equation comes from where you take k, you have to find. E is given to you as 1. Y is given to you as 9900. And N is the constant here. It's constant is this. Right. This comes from here. So to find K, you can just take 9900 by this thing. And then you can just take natural log on both sides. Take natural log on this side and then natural log on this side too. This
Ma'am,
will
we
give
need
you
only e power minus k, ma'am. We can just keep it, find the
Yes,
value
ma'am.
of e power minus k. We don't need k specifically.
Yeah, okay, that works too.
E to the power minus k का whole value सीधे ले लें.
That works too. So e to the power minus k is 99 by 100.
0.99.
Yeah. So here you can use y is given to be 5,000. That side it's 10,000 here. And then e to the power minus k is 99 by 100. And this to the power t, right? So this is going to be half equals 99 by 100 to the power t. So your t should be equal to Now you'll have to take natural log on both sides. We'll have natural log of half, and then T natural log of 99 by 100. So your T becomes natural log of half by natural log of 99 by 100. Can someone just
69,
tell me the
somewhere around
value?
69.
69, madam.
It's, you can use a calculator to solve this.
Yes, ma'am.
Okay. Is it fine?
Yeah, ma'am, it is fine. I have written a wrong value in a first equation. It is a 9,900. I just wrote 900. That's why I'm getting wrong answer in points.
Okay.
Yeah, 1 point
Okay.
something.
Let's do this one then. Give this one a try. It should be easier than others.
Option number 1. ln y upon 50 minus y.
Okay, let's
Yes, option number 1.
give this a try. You've been given a function 15 e to the power x by e to the power x plus 1. And you have to find so if you've been asked to find the inverse, it's obviously a 1-1 function. Even though you've been given the hint to find whether it's 1-1 function or not, because all the options say that it has to be a 1-1 function, right? If none of the options says that the inverse doesn't
Yeah,
exist,
ma'am,
that means it's a
option 1.
1-1 function. Okay. So let's do it this way. This is how we're used to doing this thing. E to the power x by e to the power x plus y. Then let's write x in terms of y. So this will be 15 minus y e to the power x equals y. E to the power x will be y 15 minus y, and this will give you x equals natural log of y by 15 minus y. Not getting into the what's the domain, what's the range, and all of that. We just need the inverse now, right? So it should be y by natural log of y by 15 minus y. This. Is it fine? Can we move on to the next question?
Yes. Yeah.
Okay. A suggestion here would be just because I'm not sure how this hint has been. This hint is not something that is going to help you. So just avoid this hint and try to do this question. If someone feels that they can use the hint, then they can find the answer using the hint, you can. Can we do this here now?
One second. I am getting confused in MN. I think option B is correct.
I think option C.
Okay. Okay, let's check which one's correct. So, has anyone used this hint, by the way?
No, ma'am.
Okay. So, you've been given two numbers, 8 factorial and 9 factorial 1 by 9. So, these two are the numbers. The easiest way to do this question will be just 1 second. Yeah. So, these two are the numbers. The easiest way would be, let's just raise, you have to compare these two, right? So, comparing these two or comparing by raising both of these to the power 72 is going to be same, right? And why we're raising it to the power 72? Because we want to avoid the fraction here. Want to avoid this thing, the fraction thing. That's why we're raising it to the power 72, because 72 is a common multiple of both 8 and 9. In fact, the smallest multiple of 8 and 9. That's why we're raising it to the power, both of these numbers to the power 72. And then this will give you 8 factorial. So this comparing these two is the same as comparing this. Right? And this is 8 factorial to the power 9. And this one is 9 into 8 into 7. So it's 9 into 8 factorial to the power 8. So you can just take 9 to the power 8 and 8 factorial to the power 8. Right? And then let's just take the ratio of both of these things. Let's just call this quantity A, this one B. So if you will do A by B, if your AB is less than 1, that means your A is less than B. If it's the other way, that means your B is less than A, right? So we have this thing, 9 into 8 factorial by, and this to the power 8. So this is going to give you 8 by 9, right? 8, 8 factorial by 9 actually.
Yes, ma'am.
8 factorial by 9. So this is obviously greater than 1. Because even if you just do 8 into 7, this number becomes greater than 9. Right?
8 by 9 only. Because 8 factorial to power 8 will be cancelled.
This is 8 you can write it as 8 factorial to the power 8 and 8 factorial. We'll cancel these two things. You'll still be left with 8 factorial, right? Is it fine?
Yes, ma'am. Yes.
Okay. So you will be left with this thing, 8 factorial by 9, which is greater than 1. That means this A quantity should be greater than B. That means this one should be greater than this, which is going to give you this thing. Which one's M? This is M. This is N. This one should be correct then.
It's greater than N.
Is it fine? Can we move on to the next one? We don't have any next one. Does anyone have any doubt till this
Ma'am,
in the
can you
question that
once
we
more
discussed?
explain how you solved this question?
Okay, you have to compare these two things, right? This is M, this is N. So you have to compare these two things. And we know what 8 factorial is, we know what 9 factorial it is, but we don't know what it is when it's raised to the power 1 by 8. Because 1 by 8 is not something that you can just write. If it's 8 factorial to the power 8, you know what it is. 8 multiplied, 8 raised to the power 8, then 7 raised to the power 8, then 6 raised to the power 8. But if it's 1 by 8, it's a little complicated, right? Factors don't get cancelled. So to cancel out things, we've raised both of these to the power 72. Raise this thing to the power 72, this entire thing to the power 72, and this thing to the power 72. So comparing these two is the same as comparing this thing to the power 72 and this thing to the power 72, right?
Yes.
That means it's same, and this thing is nothing but this is this. That means comparing these two is the same as comparing 8 factorial to the power 9, 9 factorial to the power 8. So if you consider 8 factorial to the power 9 A, 9 factorial to the power 8 as B, and if your A by B, this ratio is less than 1, means your A is less than B, right? And if your A by B is greater than 1, this means A is greater than B. If you
Ma'am,
do
in the
this thing, yeah.
in the division in the where we have
Ma'am,
written
isn't B 9 raised to 8 into 8 factorial raised to 8?
Yeah,
That means like
the
factorial
denominator
divided
should be
by
9 power 8.
9 raised to 8.
Denominator
Oh,
9 raised to 8.
thanks. It's 8 here. Sorry if this has caused some confusion. So this should be 8, then this is going to be 9 to the power 8. Okay, now the things
So
are
n
changed.
is greater than 1.
Now it's going to change things. This is 8 into 7 into 6 till 1. And this is 9, 9, 9. So each time, these are 8 numbers. And these are 8 numbers too, but all of these are 9. So if you can just clearly see, right? This thing, 9 multiplied 9, 8 times. And then you have 8, 7, 6. Because your 8 is less than 9, then your 7 is also less than this 9. Then your 6 is also less than the other 9. Means every number multiplied here is less than the corresponding numbers here. That means this product is greater, right? That means your 9 to the power 8 is going to be greater. That means this 8 factorial thing, 9 to the power 8, this is going to be less than 1. That means A is less than B. Then it should be the other option. And it should be this. Thanks for pointing it out. Is it clear now?
Yeah, ma'am.
Yes.
Okay.
Yes, ma'am. Now clear.
Okay.
Ma'am, I have a one question, practice assignment, question number 1.
Okay. Just 1 second. Which question?
Question number 1. If B is greater than 0 and log 4.
Okay. Just 1 second. So this is the question, right?
Yeah, ma'am, this is a question.
So P is given to be greater than 0, and then you've been given this equation. The possible values of x you're being asked. You can solve this thing if you want to, or you can just put these things here. It works too. So if you just we can just, if you can put it here, let's just do it this way then. You will have b, then 9 log b to the power 5, and then you have 10 here, right? So it will be 15 b and 1. B raised to the power 15.
Ma'am,
So
B
you
raised
should
to
take,
power 5.
it's x where we are substituting x equals b to the power 10.
We are not solving it.
No, we're just
मैं solve करा तो
substituting.
solve नहीं हो रहा था मेरे से.
Okay, let's solve it then. Since you've been given options, it's easier to just put things. Let's solve it. You have 4 log base xb and 9 log, then base is b 5x, b and 1, right? So
We can change the base of a second
yeah,
term.
let's just change why just a second term? Let's change bases of both of these. Because this is also not a very recognizable. This functions, we don't know anything about log base x type of function, right? Let's
Yes.
change this to, this will be, let's take natural log then. Natural log b and natural log x. That's 9. And this is natural log b by natural log e5, right? This is given to be 1. You solve this, you will get 4 natural log of b, natural log x, plus 9 natural log of b, natural log of 5. No, let's do
bx 5bx. 5 is outside of ln.
5,
5 ln bx.
but
5
5 b
and
and natural log of x should be separate, right?
So then 5 should be multiplied by both.
Should it be multiplied to both? It's just
Yeah,
raised to
ma'am.
the power b, right? Not to the power x. So you should take it this way. And then let's just cross multiply this. So we'll get 20 natural log of b squared plus 4 natural log of b natural log of x plus 9 times natural log of b natural log of x equals 1. This entire thing is 13 natural log of b natural log of x. What do we have to find? X
Value of,
in terms of b.
yes.
So let's take it to that side, minus 20 natural log of b squared and 13 natural log of b. While solving, have we made any mistake?
Denominator, what happened to denominator, ma'am?
Yeah,
Yes, ma'am.
thank you.
Denominator.
Thanks. Forgot the denominator. So it should be natural log of x, 5 natural log of b plus natural log of x. This is 20 natural log of b whole squared plus 13 natural log of b natural log of x equals 5 natural log of b natural log of x plus natural log x squared. So now it's just if you can see this thing. Okay,
Ma'am, can you
let's
scroll
do it.
up? वो ln x कहाँ से आया? ln x डिनोमिनेटर में, ln x 5 ln b डिनोमिनेटर में.
This
Ma'am,
one?
13 will not be there.
Why? We've cross multiplied this thing and then just multiplied these two.
तो ln b होगा ना फिर?
We have natural log of b, natural log of x 4 times, right? From here, these two terms, and then from these two, you have 9 times natural log of b, natural log of x.
is correct only.
Okay. This is, you have to find x, right? So let's just take all the, this is a quadrate, it looks like a quadratic equation. If you replace this natural log of x square with or natural log of x, if you replace with a capital X, let's say, then you will have x square plus 5 natural log of b and 13 natural log of b from here. So it will be 5 minus 13, it's minus 8, right? Minus 8 natural log of b
dx.
and then x. And if you'll take it this to that side, it's 20 natural log of b squared. Or, yeah, this works. If you'll solve this thing in terms of x, or x should be minus b, it's 8 natural log of b plus minus 8
Minus
natural
10
log of
plus
b.
2.
Ma'am, it will be
Minus 10 plus 2. You
Yeah,
can factorize.
minus 10 plus
Minus
2.
10 plus 2.
Minus 10 ln b plus 2 ln b.
It's, this is the equation, right?
whole thing can be
Ma'am, I am getting confused. I am not understanding it.
So the middle term, the middle part will be split into minus 10 plus.
Your
Is this
roots
equation
will be x
incorrect?
minus. No, it's correct. It will
Okay.
be x
Then
minus 10 ln b into x plus 2 ln b. Those be your factors.
okay, so you're just directly telling me the solution. I was using the quadratic formula.
So you can still split it, ma'am. Minus 10 ln
Yeah,
b.
yeah, you can do that, but what are we getting using the splitting thing?
X
X
minus 10
ln b.
ln b minus 10 ln b
X minus 10 log b into
x
x minus 2 log b.
X plus 2
X plus 2 ln.
plus 2.
Plus 2, ma'am.
Yes, right. So it gets factorized in this. You can use the okay, this one I think is just easier. Yeah. You can see it from here. Minus 10 plus 2 is minus 8, and then multiply it together gives you minus 20. That works too. Okay, yeah. You can directly use that AB and A plus B thing if you want to. Or you can use the quadratic formula. So these two are the factors. That means your x is going to be 10 natural log of b, or your x is going to be minus 2 natural log of b. The b is greater than 0. Okay. As it should be. So an x, we have taken natural log of x. That means this is this, b to the power 10 and natural log of b to the power minus 2. So
10 log b.
because your natural log is a 1 function, you can just remove this natural log from both sides. This also we have natural log of x, right? The small x. The small x is either b to the power 10 or you can take b to the power minus 2. These two. Is it fine?
But b is greater than 0, तो वो वाला छोड़ देंगे b to the power minus 2.
No, that is 1 upon b square. You cannot leave it.
Why
1
would
upon
you
b
leave this
square.
thing?
Is 1 by b square.
Yeah,
b raised to minus 2 is 1 upon b square.
Then why is the answer is only b to the power 10?
That must be a
It's
mistake, and
they
both of
said
these
b
are
is
correct.
greater than 0.
Both are
B
bad.
is greater than 0.
What?
In the question it is said if b is greater than 0, then possible values of x.
Oh yeah, the b is also greater than, but by b to the power minus 2 is also a possible answer. You can, if your b is greater than 0, you can calculate b to the power minus 2, right?
1 upon b square. That is also
Even if
greater
it was
than
not greater than 0, you could still calculate 1 by b square. This is just 1 by b square. Both of the answers are right, by the way.
Ma'am, you are talking about one more solution, solution, option से direct वो वाला.
Yeah,
वो-
just put it here. If you'll put b to the power 10 here, you'll have
4 log
it's
x.
log b to the power 10 b. This should be, I guess, b to the power 10. If you have a here, this means a, right? So it should be 1 by 10. So a should be 1 by 10. From here, you will get 1 by 10, 4 by 10 actually. And then from here, you will get 9 and b to the power 15. So you'll get by 15.
Guys, I have shared the PDF for the practice assignment solution. I got it from a friend. I shared it. Please take a look.
Yeah, just
Okay, thank you.
Both
I
are
know.
matched with correct answers in the solution.
is there still a doubt in this question?
No, ma'am, it is clear now.
No, ma'am.
Okay. Any other doubt?
No, ma'am.
I'm in practice assignment question number 10.
This one, right?
Yeah, ma'am. Actually, this type of questions are a bit difficult. While
Okay. CA, CB are given to be your luminosity of the bulbs A and B. And then bulb A is fx times brighter. You have, okay, this is brighter than bulb B. And your fx is 3 to the power x squared plus 1. So in simple words, you've been given what the question says. It says that your CA, whatever has been mentioned so far, is given in this equation. CA is equals to fx times CB, where x is the difference of magnitude of supply. So these are luminosities. X is your difference of magnitude. It doesn't really matter what it is. So if the bulb A is 10 times brighter than the bulb B, then the difference of the magnitude. So you've been asked the value of X, right? Because that's what your magnitude, difference of magnitude is. And your Fx is given to be 10, right? Yeah, you know that your Fx is the number of times bulb A is brighter than bulb B. So your Fx is given to be 10 because it says your A is 10 times brighter. That means your Fx is 10. And you've been asked the difference of magnitude of supply. Magnitude of supply is X. That means you've been asked to find X. Fx is given. So, and the Fx function is 3 to the power x square plus 1. Fx is given to be 10. So you have to find the value of x for which this function becomes 10. And then you can just, we don't have one here, right? It's in the power. First, you just take natural, not natural log, log base 3. Log base 3 on both sides. So you'll get log base 3 x square plus 1.
x square plus 1. Yeah.
And then you will have log base 3, 10 minus 1. And then the square root, right?
Yeah, ma'am.
It should be x. Do we have this in options?
Oh,
Yeah, it's this one, right?
this is a different form. So,
Yeah, this one. Written in a different form. But it's the same as this one, right? You can just write one as log 3, 3. This is the same as
Mhm.
log base 3, 10 by 3. Is it fine?
Yes, ma'am. Got
Okay.
it.
Oh, any other questions?
I have a question, but it is from graded assignment, so I have to ask next time.
Yeah, okay.
Ma'am, I have a question. In the
Yes.
same practice assignment, question number 3. I have a doubt in option, the last option.
Yeah, okay. Let me just paste the question here first. This one's the question you're talking about, right?
Yes.
Third one you
No,
said
third
the
one.
third one. Okay, sorry. Just 1 second. This one, right?
Yes, ma'am. And I have a doubt in fourth option.
Okay. So, wait, do we have, is this a sub question to something?
No, ma'am, no, it is not a sub
Okay.
question.
So, it says if you're the third option or the fourth one.
Actually, both. I'm not like understanding the difference.
So, your base is given to be between 0 and 1, right? B is the base, and that means your function is a decreasing function. So, it's of this form. And it says if your x is greater than b, then your log base b, x is greater than 1. Now, this thing is, okay, this looks problematic because you don't have anything to compare here. So what you do here is you take log x,
Then we
take this
can
thing
take
as,
a value from 0 to 1 and then check.
no, I don't think you need to do that. You can just simply take, or you can do this thing, log b,
Ma'am, we can
right?
solve this by a graph. It is very easy.
You
It
don't
is
have
said,
to do it using a graph. If you just see that this thing is equal to 1, then your x is greater than b, base is greater, that means your function is decreasing, right? Log base b function is a decreasing function. That means if your x is greater than b, log base b x should be less than log base this thing, right? If
Yes.
you apply log base b to both sides, the sign should change. This is one way you can do it. Was someone else suggesting something else?
yeah, graphs. Yeah.
Yeah, what is it?
It is says the x is less than greater than 0 and but less than 1. तो 1 वहाँ रहेगा और x is also greater than b. तो b means जो है वो 1 से छोटा है, तो वो 0 और 1 x जो होगा 0 और 1 के बीच में आएगा. 0 1 के बीच में कह रहा हूँ, उसके बाद आएगा वो.
Yeah, here.
या तो वो 1 से छोटा होगा, 1 से बड़ा नहीं होगा.
Yeah, that works too. You have been asked to find the value, not this point. You have not been asked to find if x is greater than 1 or not. You've been asked to find the value of
मैम ऑप्शन
log
नंबर 4
base.
what एक And which option we are solving?
Third one.
2, 3. Oh, okay. Oh, log 3 base 5 x equals to 1 wala.
Yeah, this one.
That's
Option.
4.
Okay, this one, yeah, this one's fourth one, sorry. For x, here, from here, you can just tell that x is less than 1. You've been asked about this log base b x, and you have to compare it with 1.
तो मैम जब x 1 होगा छोटा होगा तो ऑब्वियसली डिक्रीजिंग फंक्शन है, तो 1 से बड़ा ही होगा क्योंकि वो उसके उस बगल रहेगा, 1 के उस साइड रहेगा वो वैल्यू.
That then you will apply, if you're saying it's a decreasing function, then if this is a decreasing function, doesn't mean if your x is less than 1, it's going to mean that your log base bx is also going to be. That's not what decreasing means. How can you conclude this thing from here?
Could you please again explain this all?
We already have here. We were just trying, someone had to suggest something else as solution. We were testing if that's possible or not. Doesn't look very plausible to me. So the option is this. You have to compare log base bx with 1. So instead of 1, you can just, because your base is b here, you can compare it with log base bb. That's 1, right? That means you have to compare these two things. And because your b is between 0 and 1, that means your log base b is a decreasing function. Because your b is between 0 and 1. That means if your x, and this is given to you, x is greater than b. So if your x is greater than b, and log base b is a decreasing function, that means this should be true, right? But your option suggests the opposite. That means this one should be incorrect.
Okay, got it.
The last one also will apply the same
Yeah,
rule,
you
right?
can do
For the last option.
like that.
X and Y is the
Yeah,
same thing.
Yeah, you can use. In fact, this one's more clear. This one's because you have to write this as log base bb. This one's just straight up using increasing, decreasing definition. Is that fine?
Yes,
Yes.
got
Yes.
it. Thank you.
Okay.
And also, like the previous question that you copied, right? Sorry,
This
the
one?
third one. Fourth one, sorry, my bad.
Yeah, this one, right?
Yeah.
You have a doubt in this too?
Yes, actually, I got, so there are 3 options correct in this. I got 2, but I didn't got the one with log 125 by 975, log with the base.
This one?
Yes.
That's a base change
Okay.
one of second option.
That
If
is
this
same.
one's correct, yeah.
मैम
If
फर्स्ट
this
वन
one's correct, then
The
what's
natural
it?
law.
फर्स्ट सेकंड थर्ड तीनों ऑप्शन सही है.
Okay,
Same.
never mind. I got it. Thank you.
Okay. These two are basically just the same thing written in different manner. B, C. Option B and option C.
Yeah.
Okay. Anything else? Any other doubts that anyone wants to discuss? Else we can end the session then.
Ma'am, in the log questions, you were checking that increasing and decreasing part, and then you were deciding, right?
Yeah.
And ma'am, the last part, the last option, when b is 0 to 1, and so their log base b will be decreasing, as you said, and because it
Yeah.
is given y greater than x, so and the vice versa is given, that's why it is wrong, right?
Yeah, this option's incorrect. If you're talking about this one, right?
Last one, yes, ma'am, last.
Last one is this. This one's correct. Because it's a decreasing function, right? Log base b is a decreasing function. If your x is less than y, Then log base b, if you'll apply the function log base b on both sides, if you'll apply log base b here and log base b here, then this should
Inequality
change, right?
sign change. Yes.
Yeah. So this should be
Understood.
correct.
Thank you. Okay. Thank you.
Okay. Anything else that anyone wants to discuss?
Log scenarios.
Option
Sorry,
3 is also correct, I think.
But the doubt was only regarding the last two options. We have not tried the first three.
मैम ये
I'll be correct.
प्रैक्टिस असाइनमेंट में बहुत ज़्यादा ऐसा क्वेश्चन है ना जिसमें चूज द करेक्ट ऑप्शन को चूज करना पर उसमें कई ऑप्शन सही हैं.
Yeah, if you're able to select more than one, then that means it's a multiple select question.
बट मैम उसमें सिर्फ एक ही ऑप्शन चूज कर सकते हैं, वो मल्टीपल सेलेक्ट वाला नहीं है वो.
Yeah, as we discussed this, someone that was the same problem in this question, right? This one.
या मैम ये वाला.
That's all right. Both of these are correct. Any other thing? Any other question?
Typically, how do you handle this log of log, 3 times log, these things come? No? Can you please help? How do you typically handle this log of log scenarios?
Log of logs. What do you want? Okay. Depends on the question. What's the
Different
question?
bases. If you have different bases, is there any technique or guidance to see? Then there is a function here. And then we are asked to typically handle these kind of scenarios. Wanted to know what is the guidelines for handling this.
Yeah, if it's an increasing, decreasing function question about monotonicity, then we've already discussed that, right? That you can handle depending on the basis. If it's a domain question, then it's, let's say you have log base 2, then log base half, and then you have x square plus 1. Then to find the domain of this you can put anything, or if you have a square root here, then you use that thing. But first you check this one, find the domain of this, and then you intersect with the values of x. Okay. We've discussed this thing, right, in the FOGOH thing where we talked about the domain of this.
Okay.
Do you want me to repeat it?
No, it's okay. I'll go through that. I just wanted to know whether there's any, basically this log rules will not apply here, right? That you have to just keep on applying one after another from the right.
Yeah, from here keep applying and see what are the valid values that you can put in here in place of x.
Thank you.
Okay.
Ma'am, actually I have one more doubt.
Yes.
Activity 6.4, question number 3.
(6.4).
Question number 3.
Number of solutions.
Just 1 second. Okay, so this you can write as natural log of x square by 4, x minus 1. And this is log 5, which is 1 only. This thing is 1, right?
Yes,
Then you
ma'am.
take x square by 4x minus 1 e. And this is just a quadratic equation that you have to solve. So use the quadratic formula, that's all.
16e square plus 16e is वो मैं 40 minus 4e square plus 4e quadratic ऐसे कुछ बनेगा.
Yeah. Use the quadratic. Do you want me to do it here?
That's fine. I can solve that. Thank you.
Okay. What was the doubt, by the way, in this one?
Ma'am, actually, I didn't put E, so I was getting two valid solutions. And here it is given 0.
Okay.
Oh, answer is given 2.
No, answer is a 2.
Sorry,
Let's
I
do
was
it here.
getting 1 and answer is given 2.
Okay. Do I need to do it here, or can you guys do this one?
I got it.
It's just okay.
Thank you.
Can we end the session then? If there are no other doubts. Okay then. Bye guys. We'll end this
Thank you,
session
ma'am.
here.
Good
Bye
night,
bye,
ma'am.
ma'am.
I have one question, ma'am.
Yes.
Where can I find the recordings of the sessions?
These sessions, live sessions, right? It's on
Live
YouTube.
sessions.
There's a YouTube channel. You can find it there.
Okay, thank you.
Okay.
Thank you.
Okay, bye.
You told me.